Welcome to the Day 6 Advent of Code Challenge for 2022. Today we're dealing with a communication system, and we've been given a simple version of a network protocol that this thing is using. So we're given a sequence of bytes, or a string, as our input, and we're looking for a start of packet marker in that string. And the rule for our start of packet is that you must have 4 letters together that form a unique set, so 4 different letters. And we're given some examples of what that can look like, and we're asked to find at what position should we start reading after that start of packet marker. So it doesn't sound too difficult. Let's jump in and see how it goes. As usual, I've started off by loading our input text up, and that is a file with just one line in it that has our entire input stream. So we know we want to process this character by character, looking back at the last 4 characters, looking for a unique set or a unique group. So let's first get this into a sheet we can work with. So the first thing we want is to get just the first line out of that file. So we'll just do input.last.unwrap unwrap. So unwrap first time because last is optional, and second time because each element in our lines is a result. So that gives us our input text. And then we want to be looking at this character by character. So we want to turn that into an array of characters, or an iterator of characters. So let's do input text.chars, which gives us back an iterator over the characters in the string. And we'll make that mutable because we need to be able to modify it. It's an iterator. So next thing to figure out is how are we going to keep track of the last 4 values so that we can check for a unique set. So we could use a few different data structures here. We need something that has order and something that has remove and add operations. So we've got a few options. I'm going to go with a vectq just because it makes sense to think of it that way, as like a sliding window. So vectq with capacity, we're going to stick to 4 because that's how many things we want to keep track of for our marker. That's our buffer. And then we could start looping now through the stream, but we'd have to deal with initialization conditions of, okay, I've put something in my buffer, has it reached size 4 yet? Has it gone over size 4 yet? Do I need to remove something from it? So let's just skip past that problem and initialize the buffer. So we'll do an extend on the buffer to add to it, and then we'll grab the first 4 things out of our stream. So grab chunks, and we want 4 elements, and we'll unwrap that and iterate through it so that the extend function knows what to do with it. And then we need to grab that because it's a unstable feature. So that's our initialized buffer. So now we can start running through the remainder of our stream. But we don't want to just run through the stream. That will give us back character by character. We want to run through our stream, and at some point we're going to grab a position back. So let's run through the enumerated version of that stream, which tells us what number character we're currently processing into that stream and what character we're processing. So we get both at the same time. So that will be position and character. Okay, so first job then is to check whether we've already hit our condition, which is a unique set of characters for our marker. So the way to do that would be to just create a hash set, or certainly one easy way to, from an iterator over the buffer okay, and it doesn't know the type, so let's give it a type. There we go. So not quite happy yet. Why is that? Because it thinks it's got a reference back, because I need to call cloned. There we go. So we're going to take a copy of our buffer, turn it into a hash set, and then we can check whether we've got 4 unique characters. So if the hash set length is 4, then we're done and we can stop. Otherwise, we need to move our window along a bit, move our buffer along. So we want to remove the last element from the buffer, or sort of the first thinking left to right, I guess. So we'll pop front and then push back to add the new element in, which will be ch, our character that we're currently looking at. So that's nearly there. That will run through and it'll find the right position to stop, but we need to know what that was. So let's grab ourselves a variable to track that. Final position. And we want to initialize it to 4 because we've already consumed 4 elements of the iterator. So this position will run from 1 onwards because it doesn't know about those first 4 things that we've already consumed. So then when it comes to tracking our final position in here, we can say final position plus equals, and then the current position, and that should be our answer. So that's how far into the input we should start reading after our marker. Let's check if that runs. Let's give that a kick with cargo run. And it's telling us 1238 is my answer. So let's give that a check. So is it right? Yeah, excellent. On to part 2. So part 2 looks suspiciously similar to part 1, except that it's asking us to look for a start of message marker, which is 14 distinct characters. So I think possibly the idea here is for people who've done this maybe with a few variables for part 1, where you've only got a few things to keep track of, you now have to think of a solution that will deal with more elements, more characters that need to be checked, but we should be okay. So let's jump in and see if we can solve part 2. Let's go ahead and copy forward the stuff we're going to want to reuse. So we want to copy the stream again because we've already consumed that iterator. We want to overwrite our buffer with one that has a capacity of 14. We want to take the first 14 elements of our input, which is fine. There are far more than 14 elements. And we know from the first answer there's over 1,000. Final position needs to be initialized to 14. We can then enumerate our stream the same way we did. And we need to look for 14 elements in our hash set. And otherwise, that should work exactly as it did before. So let's give that a run and see what it does. Check it with cargo run. And it's saying 3037. So let's put that in, see what it says. Alright. And that's correct. So suspiciously easy today. So that probably means we've got a more difficult stream processing problem to look forward for tomorrow. So I will see you tomorrow for that.